Can we refuel Webb at L2 when it runs out of propellant? What will the Dragonfly octocopter see on the surface of Titan? Will discovering life on Mars stop us from going there? In our extended Q&A plus edition on Patreon, what are some space things that I'm hoping to see in my lifetime? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Skeetch, are we expecting to see rain or rivers on Titan where Dragonfly will be landing? What season is it on Titan? No, unfortunately, the Titan Dragonfly is going to be going near the equator on Titan and not going to the North Pole. And that's where all of the cool methane liquid is happening. The methane rain, the methane rivers, the methane lakes. And it would be amazing if Dragonfly could go up and fly around that area, but it's been sent to the equator. There's a lot of interesting geological, scientific questions that they want to ask about that region. And it's a bit of a safer place for the helicopter to fly than to go to the pole. Easier to communicate back with Earth. And so they went with that region. And so maybe some future mission is going to go to the North Pole and give us more information. It would be nice to get an orbiter back at Titan. You can learn a lot just looking down from above. And of course, my dream is a boat. Right? A boat or a submarine on Titan. Now that would feel like we're living in the space age. I want to kill myself. That's the username. Just be clear. Why does James Webb have to do this figure 8 movement constantly? I thought the point of the Lagrange is that it can stay put. So the Lagrange points are sort of actually zones. They're not specific points in space because they exist due to the interactions of gravity of the two objects between the Earth and the Sun, in the case of the one that James Webb is using. And this is not a stable point in space. The Earth is following an elliptical orbit around the Sun. And so sometimes it is thousands of kilometers closer at one point in its orbit than it is at another point in its orbit. And so there is no Lagrange point. There is just a kind of Lagrange zone. And so with the L1, 2, and 3 points, which are lined up between the Earth and the Sun, that you have to still expend propellant to remain as close to that Lagrange point as you can. Now, if you do, there's a minimum amount of fuel that you can be able to expel that will keep you in that area. And then that'll mean that you won't have to expend even more fuel to be able to remain in this special place near the Earth. But you still have to use propellant. And so what James Webb is doing is that it is not sort of hovering at this one single spot. It is in this orbit that is going around in a, it's going in its own ellipse circle around what is the average place where the Lagrange point is, and that it has to use its propellant on board occasionally to get it back into the perfect orbit to remain going around the Lagrange point. So unfortunately, you can't just sort of get yourself to the Lagrange point and just like hover. Doesn't work that way. SantiagoMK, could James Webb be refueled? There are no plans to refuel James Webb. Like nobody has put it into a future mission that they're going to go back and give it more fuel. Now, theoretically, it could be refueled because when it was launched into space, it was on top of its upper stage and there were various lines. There was like a sort of an attachment that clamped it onto its upper stage. There were ports that they used to refuel it. And so theoretically, they could send some rescue mission or send some mission out to James Webb, clamp on to the port that was used to keep it onto its upper stage, access its fuel lines, and be able to deliver more propellant to it. But, it probably won't happen. So I wouldn't expect, but it is theoretically possible. And people have proposed that they could do a mission to do it. Beau Danner, if you could gift Venus with any moon in the solar system, which would it be? And why would it be Titan? It wouldn't be Titan. If you moved Titan closer than the asteroid belt in the solar system, then it would grow a tail and it would be destroyed by the radiation coming from the sun. You'd be left with whatever is the solid rocky core of Titan. It would ruin Titan's beauty. No, the only moons that you could give to Venus would be something that is very rocky. Like maybe you could share one of the Martian moons with Venus, I guess, or like give it an asteroid. Give it a big asteroid, big dry asteroid. Psyche would be cool, big metal asteroid. That'd be all right. But no, you don't want to give it Europa or Enceladus or Titan. You'll just destroy them. You madmen. Billy Griffith. If we find life on Mars, even just small organisms, should we abort going there since it's not our planet if something is alive there? Humanity isn't going to care, right? We're just going to keep going. Even if we do find organisms, we're going to be like, well, sucks to be you. We're here now. That's just how we roll. But I think, if there is life on Mars, it's very important because it tells us about the evolution of life in the universe. Did life evolve on another world within the solar system completely independently? What are all the different kinds of variations of that life are out there on Mars? Is it DNA based? Do we share a common ancestor? If not, what is its life based on? Like, these are all really important questions. And then it's going to be a race against time. Are we going to be contaminating that life with our own Earth life? Are we going to be filling up all of the potential living places with cyanobacteria? Cyanobacteria is ready to go. Like it just says, sign me up. Water bears, tardigrades, right? And cyanobacteria and various lichens are ready to go to Mars. So, any indigenous life forms that are already there, better watch out because humanity is coming, which is too bad. And so I think, because the question of if there is life on Mars, how did it form, is so important that we need to be really, really careful about how we approach this. We can't just be cavalier about it and just go, well, our planet now, because we may overwrite the history and then we won't be able to find out the answers to these questions. And so I think we should be patient. We should take a little bit of time to look into this. Veerendra Kumar, what do you think about double or triple black hole systems? We know that double black hole systems are out there because that's what the LIGO detector is finding, that astronomers are detecting the gravitational waves that are coming from binary black holes that are crashing into each other and sending out gravitational waves. There must be triple black hole systems out there. They're going to be rarer, but they're going to happen too, because we see triple star systems. The largest stars, the giant stars, tend to be in multiple star systems, 2 stars, 3 stars, 4 stars, etc. It's the red dwarfs, which are the most common stars, that are singletons generally, but it's the larger stars tend to be in larger systems. And so I'm sure out there are 4 black holes in a system because they were once 4 giant stars and they all detonated as supernova and they all turned into black holes. And now all those black holes they're spinning around each other and in a big quadruple star system. It's time to shout out our new patrons at the $5 level and above. Glenn McNeil, Daniel, Jamie Cotton, Bird Patrick, Gear Lanniscog, Vivian Rousseau, Jack R. Woods, Norm W., Michael Keller, and Joshua. Join the community at patreon.com/universe today. Klondike 69 None. Will we or have we already imaged any asteroids or asteroid belts in or around other solar systems? Yeah, there have been debris disks, is the technical term, in other exoplanetary systems that have been seen, and in several ones. A lot of the times these are seen in very young systems, ones that the planets are still forming. But yes, astronomers have detected the presence of, an equivalent of asteroid belts in other star systems. Tim G, are you in or out on Mike Brown's Planet 9? I'm just a journalist. I'm not an astronomer, so I don't have an opinion on this. Mike Brown has discovered many of the large objects in the outer solar system. He found Eris. I don't know which of the dwarf planets he found, many large Kuiper Belt objects. So, if anybody knows his stuff, it's Mike Brown and Konstantin Batygin. Other astronomers have looked at the data and done the math and agree that that a large object in the outer solar system would explain the movements of various objects. Now it's a question of finding it. And good news, Vera Rubin is almost here, and that will have the ability to find Planet 9. So we don't need to have an opinion. It hasn't been found yet. We just wait for a telescope to pick it up or fail to pick it up. And then other theories will have to sort of come forward to try and explain the movements of the objects in the Kuiper Belt. Kasie Ream, if some massive stars can collapse into black holes without a supernova, how do we know that won't happen to Betelgeuse? Or could it? That would be anticlimactic if it did. Yeah, this is called an unnova, or a direct collapse black hole. The traditional idea is that when a star reaches the end of its life and it uses up all of the fuel in its core and the outer layers collapse inward and you get this compression and this enormous amount of energy, you get the black hole forming because there's like too much matter and energy in a small enough region, but you also get this release of energy. Essentially all the stuff bounces off of the, piles up and explodes with an enormous amount of energy. But astronomers have seen examples where there was a progenitor star out there in the cosmos, and then they went back and checked a few years later and it was just gone. The star had just disappeared. And so one idea that's happening is that these stars, they're going through this process, they're becoming a supernova, they're collapsing inward, but the black hole is capable of eating all of it. And so instead of it reaching some point where it's just too much and the thing explodes, the black hole just forms and just gulps down the entire star. And then now you're just left with a black hole. And so could this happen to Betelgeuse? We don't know. I mean, we don't know if this is actually the explanation for these disappearing stars. And if it is, we don't know what is the mechanism. Like, do you need some kind of perfect turbulence in the star to be able to make this thing happen? We don't know. So maybe it would be crazy. Wouldn't it be crazy if Betelgeuse just disappeared? That would be bonkers. Mufasa Putasa. It's been a handful of years since the first gravitational wave detection. What have we learned about the universe by studying gravitational waves until now? I mean, we've learned so much. The greatest discovery that we made, I think, was that the speed of gravitational waves is the speed of light. Like when the kilonova went off in 2017, astronomers did the math, and yes, indeed, the light that came from the collision between the two neutron stars and the gravitational waves took the exact same amount of time to get to us. And so finally we got this perfect confirmation that light and gravity move at the same speed. But there's been a bunch of other stuff. There has been black holes that have merged that shouldn't be possible. When supernova go off and can form a black hole, there's a kind of a maximum size that you can get for a black hole. And then there's this gap, and then you can have black holes form at the other side of this gap. And I forget the exact number. It's like you can't have a black hole greater than 65 times the mass of the sun, and you can't have a black hole less than 85 times the mass of the sun. And there's like this gap in between that the theory predicts shouldn't exist. And yet astronomers have seen black holes with that mass colliding with each other. And so maybe our understanding of the physics doesn't work. But at this point, we're now seeing a black hole merger every couple of days with LIGO. Like, they're happening all the time. They're happening so often that we just don't report them anymore because they're not interesting. They're not new. They're not spicy. We're waiting for something really cool to happen, like a white dwarf black hole merger, or a white dwarf neutron star merger, or an asymmetrical supernova explosion, or a new regime of gravitational wave telescopes to be built that can allow us to detect like supermassive black holes merging. So unfortunately, it's like, what have you done for us lately? Eric D. Wade, what happened with Beam? Did they just abandon it because Bigelow went out of business, or did they just leave it on the ISS as an extra storage closet? Yeah, the Beam module, this is an inflatable module. It's built by Bigelow Aerospace, and it was launched and installed on the International Space Station. And it's still there. Like, I'm sure it's going to come down with the International Space Station. And originally, like, NASA was trying to invest in inflatable modules to see if they would have a better performance than the tin can aluminum style rigid modules. And it worked well. Now, Bigelow Aerospace did go out of business, filed for bankruptcy, and so all of the future plans from Bigelow didn't come together. But other companies are working on inflatable modules and are testing them with NASA's supervision. And so we could see space stations in the future, maybe something attached to the lunar gateway or something installed on the surface of the moon as an inflatable habitat. So the idea is still really strong, but we just it's gonna have to come from a different company than Bigelow. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. This week's bonus question is all about the space things that I'm hoping to see in my lifetime. I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you everyone who put your questions into the YouTube comments, as well as everybody who joined me for the live show. Now, we record the show live every Monday at 5 p.m. somewhere in the world. We'll put a link to where the next episode is going to be. There'll be an announcement here on the channel. The live show is amazing. It lasts for about 2 hours. I get about 500 or 600 people watching. They ask tons of great questions. We get through dozens and dozens of them, lots of back and forth. So if that sounds like a good time, you should definitely come and join us for the next one. Now, I'm going to shout out some more YouTube channels, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Barely Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Kilsinen, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Monzo, Paul Roebuck, Rank Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I've got a couple of YouTube channels here that I want to shout out today. Now, I'm having a hard time finding like really small channels, but there are some medium-sized channels that I would love to let you know about if you weren't already familiar with them. The first one is Ed Ting, and he is a telescope reviewer and has been reviewing for all the major websites, and just has got great reviews, has looked at dozens, 100 telescopes in his time, and so he understands every telescope that's out there and can give you good recommendations on what to get. Now, I'm sure he would also say get a Dobsonian, but with more nuance. The next channel is SpaceMog, and I've done collaborations with SpaceMog in the past, and of course she is a cosmologist. She knows a lot about dark energy, but a lot of other subjects as well that she covers on her channel, and I just don't understand why she doesn't have an enormous number of subscribers. So she is legit scientist, so definitely check out her channel. And the last channel that I want to point you at is Philip Sauce. And he is a reporter. He's been working for NASA spaceflight for many years, specializes in reporting what's happening with the Artemis program, and has just got really good coverage about what's going on with spaceflight. And so, again, if you are really interested in not just what SpaceX is doing, but sort of what the larger industry is doing and what's happening with the plans to return to the moon, definitely check out his channel. All right, but please keep the recommendations coming for any channels that you are familiar with so I can give them a shout out. All right, we'll see you next time.